Nanam alayam karunalayam namami bhagavatpadam Shankaram lokashankaram. Shri Gurubhyo Namaha. Srimati Archana Raghuram, an independent researcher, a TEDx speaker. She is a former CEO of United Way Chennai, an international non-profit organization, a Forbes Award winner. She was also awarded Fast Company's 100 Most Creative People, and more important, a heritage and a Vedanta researcher. Srimati Archana Raghuram made volunteering fashionable at IT services firm Cognizant, motivating 50,000 employees, mostly millennials, to dedicate more than 900,000 hours after volunteering hours over 7 years to educate and build school infrastructure for underprivileged children, training teachers, offer career counseling, and more. Srimati Archana Raghuram runs her own YouTube channel on a subject that's pretty close to her heart, temple, book, and science. It has over 31,000 followers. Srimati Archana is a BE Computer Science graduate and a rank holder from the University of Madras. Srimati Archana has completed an executive MBA program on sustainable business and corporate responsibility from a Swedish institute. She was one of the 25 people selected for sponsorship by Swedish Institute and applicants all over India. Today, she's here to deliver her talk on quantum and Vedanta. She has earned some frequent flyer mails of sorts from a spiritual journey standpoint by being here for the second time, as she was with us in Ayodhya when the Ananda conference was there, incidentally on the same subject. So I welcome you here, ma'am. Thank you. I would request all of you to have your cell phones on silent mode, please. Thank you.
To my Guru, Swami Paramarthananda ji, and all the gurus and teachers who have enriched my life with their knowledge, I begin this presentation. Today, I want to talk to you about quantum physics and Vedanta. Two things I want to convey through this presentation. Why is it that quantum physics and Vedanta are often mentioned in the same breath? And how these subjects can add value to each other. These are the two things which I want to convey through this presentation. So let us begin with the Nobel Prize for Physics in 2022. Dr. Ravi Shankar mentioned how it was awarded to three physicists, Alan Aspect, John Clauser, and Anton Zeilinger, whose experiments, technically all those things which he described, but in effect, the inference of these experiments, the inference of this proof was that the universe is not locally real. The universe is not locally real. So what do we mean by this? What does physics mean when it says universe is not locally real? So physics has clear definitions for everything. For example, I'm here and I'm seeing all of you here, right? So if I ask you a question, are you real? Your answer would be yes, we are real, of course. But physics has a definition for why you should be considered real. So any real thing in the universe has to follow two criteria. First, it should have an objective existence, and it should have an independent existence. What do we mean by objective existence? When I look away, I'm looking at you now. When I shut my eyes, you don't disappear. You continue to exist. That's an objective existence. What is independent existence? Anybody who comes here can verify that you all exist. The number of people, the kind of clothes you're wearing, the dimensions of this room, anybody can verify and agree on all the parameters of the room. So that is objective and independent existence. So let's say tonight I'm dreaming of this room. I have the exact same experience. I feel the same thing which I'm feeling right now. I can see all of you vividly. But is that real? Physics says that is not real, because of two reasons. When I stop looking, that auditorium will cease to exist, and nobody else other than me can see that auditorium. So this is the definition of real according to physics. So what we have found, what quantum physics has found, is at a fundamental level, at the level of electrons, protons, neutrons, and now they are discovering even at the level of atoms and molecules, particles do not adhere to these two conditions. They do not have these properties. They don't have independent and objective existence. I will explain what it means using an experiment later on, but this is what was found by physics. So since the entire universe is made up of these fundamental particles, we have to conclude that the universe itself is not real. So that is the first conclusion. And what does this prefix locally means? So there is another principle in physics called principle of locality. It is derived from one of the oldest law in physics. You know, the Newton's 3 laws were the oldest laws in physics, and the first law says everything continues in its state of rest or a motion along a straight line until it is acted upon by another force. So the corollary is, in order to change something, you have to physically touch it with a force. It has to be touched. Change can only be effected by touching an object with a force, either physically or with a force. So this imposes a speed limit on how quickly you can effect a change. For example, let's say I want to break a rock on the surface of the sun. What is the minimum time it will take for me to achieve that? It takes 8 minutes for light to reach the sun. And the fastest anybody can travel is at the speed of light. That's the cosmic speed limit. So it has to take me at least 8 minutes or more to achieve that feat. So this is called the principle of locality. Things can only be changed when they are touched, and this cannot happen faster than the speed of light. And what quantum physics has found is there's a certain set of particles which define this. They seem to be influencing each other instantaneously across millions of light years. So they seem to be defying this most basic principle of physics. So the scientists have concluded that the universe is not locally real. In order to understand the significance of this, especially because all of you are students of Vedanta too, we need to go back to Vedanta, the Upanishads. First of all, for Upanishads are many things. You can think of them as the oldest philosophical texts. And those of us who have studied under gurus, traditional gurus, you will know that these are all revelations. They are apaurushaya. They don't have human origin. But as a person who has always been passionate about science and Vedanta all my life, I also like to think of Upanishads as the oldest theoretical science book in the world. What is a theoretical physics book typically? It asks ambitious questions and tries to answer them by applying logic and reasoning. We all know of famous thought experiment by Albert Einstein. How did he arrive at the theory of relativity? He sat in his patent office and imagined traveling on a wave of light. And just by thinking through deeply, logically, in a step-by-step manner, he arrived at groundbreaking revelation about the nature of the universe. And Vedanta does that too. It asks ambitious questions. And when you look at texts like Nyaya, they are oldest thought experiments ever conceived. So look at, this is the first Upanishads I read. The first Upanishad I learned was Mundaka Upanishad, so it's my favorite Upanishad. And it begins with the student, Angiras, asking his guru Shaunaka, the other way around, his student Shaunaka asking his guru Angiras, what is it by knowing which everything else is as good as known? So, and those of you who are in physics, who are in the field of physics, know that even today science is grappling with this question, a grand unified theory which will explain everything in the universe. And that's the kind of ambition Upanishads have. That's the kind of questions they tackled. And they tackled it not in a fatalistic manner, but with logic and debate and analysis, applying deep thinking. And based on this, they have come up with some really deep revelations about the universe. You know, they're so beyond anybody's imagination that you have to think that it can only be arrived at through God's grace or really deep thinking. Okay, so I'm going to talk about those aspects of Vedanta which are relevant to quantum physics. So these are the two aspects I want to touch upon. So what Vedanta concludes that the universe is not real. It is Maya, it's Mithya, it's Vyavaharika Satyam, not the ultimate reality. So if the whole universe is an illusion, it's Maya, what is real? There is only one real thing in the universe, and that is Brahman. And Brahman is nothing but pure consciousness. If you have to define Brahman, we can use one word, Chit, pure consciousness. So this is the conclusion of Advaita Vedanta. That's why we call it Advaita. There is no second thing in the universe. There is only one thing, and that is Brahman. That is pure consciousness. So, but it does not, on the face of it, it does not make sense, isn't it? The world we look at is so real, so tangible, and sometimes more real than we want it to be. And how can consciousness give rise to so much variety? Things, a star is different from a mountain, a human being is different from an animal. How can all this be products of one consciousness? That's the question which will automatically arise. So Vedanta uses several analogies to explain this, explain why this is true. One of the famous analogies is that of a dream, swapna. So when you dream up this whole world in your mind, right? So if we can understand the relationship between you, the dreamer, and your dream, we can understand the relationship between Brahman and universe. So let us take the first relationship. The entire dream, when you're dreaming, the entire dream happens within you. You're dreaming of the galaxies, the cosmos, the mountains, rivers, other people. All of it is happening within you. You create, sustain, and destroy your dream. The dream arises in your consciousness, is sustained in your consciousness, and resolves into your consciousness. So similarly, Brahman, the consciousness principle, gives rise to this universe. The universe is sustained in this consciousness and resolves into this consciousness. Now let's look at the second relationship. So what is everything in your dream made up of? So you're dreaming of many different things, tables, chairs, stars, galaxies, rivers, all have different properties, look different, feel different, but what are they all made up of? They're all made up of your consciousness. So all the multitudes which look so dramatically different in your dream are made up of only one thing, your consciousness. Then there are many relationships you can derive out of it, but this is a very important relationship, the third one, which is relevant from a quantum physics point of view. So how do you create your dream? How do you create your dream? You create it by simply witnessing it. So can anything exist in your dream which you don't see? Can anything exist in your dream which you don't see? For example, let's say you're dreaming of stars, galaxies, and then next minute you're dreaming of a room, of this room. What happened to the stars and galaxies? Are they there somewhere for you to go and see? No. What you see does not exist. Only thing that exists in your dream are the things you see, and it is your seeing that gives rise to the whole dream. So that is, you're just a witness of your dream, and merely by witnessing your dream, you give rise to every object in your dream. And it is your witnessing that lends existence to everything in your dream. So this is what Vedanta calls Sakshi Chaitanyam. This is what is the nature of Brahman too. Brahman creates the universe by simply being the Sakshi, by being the witness of the universe. So Brahman is called Sakshi Chaitanyam, and that's why Brahman is called Akarta Abhokta. So whatever happens in your dream, let's say you murder somebody in your dream, just for the, it may not be a good analogy. It doesn't affect you when you wake up, right? You can't be hung for it because you are not doing anything. You are not a karta or bhokta of your dream. You are merely a sakshi, a witness of your dream. And this is what is represented in this image of Mahavishnu. The oldest image of Mahavishnu is him reclining on his serpent bed and dreaming up the universe. So this Vedantic analogy of dream is represented in this form of Mahavishnu. You know the Puranic story, right? Goddess Yoganidra enters him and he goes to sleep, and from his, and this whole universe is nothing but a product of his mind. He's in Yoga Nidra and he creates the universe. So it is the representation of this ancient Vedantic analogy. So now we have three conclusions. World is not real, it's Maya, it's Mithya. There is only one thing in the universe, which is consciousness, Brahman, and this consciousness is only an observer, Sakshi Chaitanyam. So we have these three conclusions of Advaita Vedanta. Now let's say what quantum physics says. A quantum physics says that a particle is not real. And because the whole universe is made up of these particles, the universe is not real too. And it is an observer that brings a particle into existence, which we will see in the upcoming experiments. Since an observer is required to bring a particle into existence, universe cannot exist without an observer. So these are the two conclusions of quantum physics. So many times, often, especially among the scientific circle, when you look at these two proclamations, they think it's just a semantic issue. What Vedanta says by Mithya and what quantum physics says by not real is not same. What Vedanta means by a Sakshi and quantum physics says by an observer is not the same. So I'm going to take you through what quantum physics means when it says an observer is required, and we'll see how much it correlates with Vedanta's Sakshi. So one of the most defining experiments in quantum physics is this double slit experiment. This experiment was carried about little over 100 years ago, and what started with this experiment has resulted in this proof that the universe is not real. And it looks simple enough. So this is how the experiment is set up. On one side, you have an electron gun, which is shooting electrons. And in the center, you have a divider, which has two slits. So the only region through which the electrons can cross over to the other side is through the slits. Okay? And the experiment gets its name because of these two slits, double slits. And on the other side, you have a screen which will record whenever an electron touches it. Whenever the electron touches the screen, it will record that position. So this is the setup of a double slit experiment. So first let us understand what was expected. Now you can think of electrons as small, tiny balls. So you're shooting a set of balls at this double slits. So they're going to cross through the slits. Anywhere else they hit, they'll be bounced off. So they'll cross only through the slits and hit the screen parallel to the slits. You can imagine that, right? So you will have predominantly the electrons will be hitting the screen parallel to the two slits. So you will only see two bands on the detector, on the other wall, isn't it? This was the expectation. But instead, what did they see? Instead of these two lines, what they saw was this interference pattern. Interference pattern is a series of dark and light lines spread across the entire stretch of the screen. You can see a lot of parallel lines, not two bands, a limitless number of bands spreading across the entire stretch of the screen. And this was surprising to the scientists because a particle cannot create an interference pattern. The interference pattern can happen only when two waves collide with each other. So let's understand this better. So what is a wave? Let's say you drop a pebble on a still surface of water. You will see those ripples across the surface of the water, isn't it? That's a wave propagating on the surface of the water. And when two waves collide with each other, they form a distinct pattern. And that's called an interference pattern. It looks like this. Two waves collide with each other. They form a very distinct pattern, which is called the interference pattern. And what you're seeing in the double slit experiment is a cross-section of this pattern. So now let us imagine what is happening in the experiment. For us to be able to see this interference pattern, what should be happening? When you shoot an electron, it's not an electron that is going towards the double slit. Instead, those ripples which you see on the surface of water is propagating towards the double slits. So when a wave which is spread across in space hits the double slits, it will enter both the slits. If it's a particle, it can only enter one slit, isn't it? But a wave is spread out. It's a ripple. So it will enter both the slits and it will emerge from on the other side as two waves. And these two waves are overlapping with each other and you're seeing the interference pattern. This is what is happening. So here is a small animation of how this happens. So you're sending a particle which is a wave. It is going and hitting the two slits. From the slits, it's emerging as two waves. Then it's interfering with each other. And what you see on the screen is this interference pattern. So how can this happen? This is not possible at all because wave and a particle are two different entities. A wave is located in space. A particle is located in space. A wave is not located in space. A particle has a shape, momentum, so many properties which waves don't have. So they are so diagrammatically opposite. How can a particle behave like a wave? It was very difficult to wrap your head around it. So what the scientists did is, let us see what is happening at the double slits. All the action is happening at the double slits. We will place a camera, a detector in front of the double slits to see how this is happening, what is happening at the double slits. So when they placed the camera, what do you think happened? The interference pattern disappeared and you got only those two bands. So the particles started behaving exactly as you would have expected them to behave when they were particle. So when somebody was recording the particle, it was behaving like a particle, and when nobody was recording it, it was behaving like a wave. So after multiple iterations of this experiment, the founders of quantum physics concluded this. Once you see an experiment, you have to conclude, right? When apple falls on the earth, you conclude its gravity or wrapping of space and time. You have to draw conclusions from an experiment. So based on how the double slit experiment worked, the founders of quantum physics concluded that the particle has no real existence until it is observed. In effect, a particle is not real until it is observed. Niels Bohr and Werner Heisenberg concluded this. This is called the Copenhagen interpretation of quantum mechanics, and it's the most accepted interpretation of quantum mechanics. So now the question arises, who is the observer? That's a question which both science and Vedanta are asking, isn't it? And this is where many people feel there is a difference. But if you look at this experiment, your first thought would be the scientist has no role to play in the particles appearing, because the scientist is simply placing this camera in front of the double slits. After that, he doesn't participate in the experiment. So it is this camera which is recording the particle that is causing the particles to appear, the wave function to collapse and the particle to appear. It has nothing to do with the conscious observer. So this was the initial conclusion of most physicists. But then what happened, several different versions of double slit experiment was carried out, which showed that this is not the case. A conscious observer was essential for the particles to appear. So I'm going to show you one example of this experiment. There are many examples, but due to the paucity of time, I'm going to show you one example. Now you have the exact same setup. You see the camera, you place the camera in front of the double slits. What happened in the previous version, you remember, when you placed the camera, you got two bands, isn't it? The interference pattern disappeared. Now what happened, they placed a camera, and what the camera would do, as soon as it records the particle, it will delete the recording. It will record and delete, record and delete. That's what this camera will do. This is a schematic representation of a complex experiment. So exactly how they went about doing it, you'll have to look up the actual experiment. But this is how, basically this is what they did. When the particle was passing through the double slit, they'll record the particle and the camera will immediately delete the recording. So what happens when you delete the recording? The scientist will not be able to read, will not be able to know where the particle is, will not be able to read the recording. You know what happened when they did this? The interference pattern appeared. It was as if the particles knew that even though this thing is recording me, nobody will be able to know my position, so I am free to behave like a particle. So like this, there are many versions. This is just one version. This is called the quantum eraser double slit experiment. You have delayed choice double slit experiment, many versions, because it is so hard to accept that an observer who has nothing to do with the experiment is impacting the behavior of the particle. They tried everything to prove that it is not the conscious observer, but it is the detector which is causing the particle to appear. But in every version of the experiment, it only showed one thing. What makes a particle appear is the ability and the intent of a conscious observer to observe it. A particle does not exist until it is observed. A conscious observer is essential for bringing the particle into existence, and the intent and ability of the conscious observer is the determining factor. So I will later on, I'll show you another version where the point number 3, you will understand what I mean by that. So I want to take, this is called the observer effect in quantum physics. Nothing exists until it is observed. Nothing exists until it is observed. So here we come to the definition of real. So what do you call something which exists only when you see it and ceases to exist when you don't see it? You call it an illusion, you call it a dream, you call it not real. So that is what physics is telling about particles. It comes into existence only when you observe and does not exist when you are not observing it. So it is not real. So I think I will leave it to you to decide whether this is what Vedanta says. This is what quantum physics says about why particle and hence the universe is not real. So based on this finding, the founders of quantum physics like Niels Bohr said this: everything we call real is made up of things that cannot be regarded as real. If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet. Okay? And to understand the impact of this observer, observer looks like a puny person with no power, and to understand the influence and impact of the observer, you have to look at another finding in quantum physics. This is called the entangled particles. Entangled particles is a special type of particles which is predicted by quantum physics, but later discovered. Nobody believed that it could not, that this kind of particles could exist. In fact, Einstein used this to show, to keep telling that quantum physics is wrong. But then they discovered these particles. So what is special about these particles is that they are mirror images of each other. They will exactly mirror each other. So if one particle has an upspin, the other particle will have a downspin. If one particle has a certain momentum, the other particle will have an equal and opposite momentum. They're like twins who are mirroring each other. And this mirroring, is not limited to any distance. So if one particle is here on Earth and other particle is billions of light years away, even then they will be perfectly mirroring each other's properties. So you may wonder why this is strange. If you create two particles and send it to two different parts of the universe, naturally they will be the same, isn't it? You may think that. But then we have to go back to the observer effect. No particle exists until it is observed. So if you create an entangled particle, what you're creating you don't know. It's just they are equivalent to two waves until you have observed them. They do not have any property like spin or momentum or mass. Okay? And so what happens now? Now what are you doing? When you observe one particle here on Earth, the other particle, even if it's billions of light years away, will pop into existence instantaneously with opposite set of properties. So by observing one particle here on Earth, you create another particle billions of light years away, transcending time and space. And this is what you call defying of principle of locality. You cannot happen because nothing can travel. If principle of locality is true, if I create a particle here, observe a particle here and create it, it comes into existence. For billions, it should take billions of years for the other particle to get this information and come into existence, right? But that doesn't happen. It is as though they are one particle, although they are separated by billions of light years. That's why they say that the universe is not locally real, because the principle of locality these particles violate. So physics says that, and I would like to say this, that the influence of the observer transcends space and time. That is the power of observation. You think of observation as a passive thing, isn't it? But look at that, by observing a particle, you're able to influence a particle billions of light years away, which nothing in physics can do, only an observation can do. And I want to give you an example of how this observation transcends time and space. This is an example of a double slit experiment using entangled particles. So as I said, physicists were trying their best to prove that it is only the detector that is causing the particle to appear and not the observer. So what they did, once they discovered entangled particles, they decided to do several experiments using entangled particles. So using entangled particles, what you can do is, you can observe one particle and know the position of the other particle. That is the beauty of entangled particles. They reflect each other's properties. So when you can create entangled particles, do the experiment with one pair of the twin and observe the other twin. And you can observe the other twin after this experiment is complete. Say the red is one pair of the twin and green is the other pair of the twin. You're sending the red particles through the double slits, and it is passing through the double slits and hitting the screen. And after this is complete, you're having your detector to observe the twin particle. So not even during, but after this whole process is complete, you're observing the twin particle. So what should happen? During the whole process of its journey through the double slit, nobody is observing this particle, this red particle, and nobody is observing its twin also. Even then, the red particle seems to know that in the future somebody is going to observe my twin, and it changes its behavior accordingly. So the power of observation seems to transcend time and space. So these are based on this. Now let us look at the two conclusions of quantum physics and two conclusions of Advaita Vedanta. Universe is not real, quantum physics says. Universe is not real, a mithya, Advaita Vedanta says. You think about, based on what I said, you take a decision on whether they mean the same thing. Observer is essential to bring the universe into existence, quantum physics says. And Advaita Vedanta says that the observing consciousness, Sakshi Chaitanyam, brings the universe into existence. Okay? There may be slight, in the second one you may wonder whether it means the same thing. So we will try to resolve that in the next few slides. So why should we learn this? I know it is a matter of pride. Hundreds of years of scientific research has led us back to the wisdom of our sages, and it is definitely a matter of pride. But that is not the only reason we should be learning these two subjects. We should be marrying these two subjects. I think they have a lot of value to add to each other. So far, science has always believed that consciousness is not consequential to the working of the universe. It's just some incidental thing which popped up in one remote corner of the universe. Universe is only matter and is governed by laws. Now quantum physics has brought consciousness to the center stage almost of science, of physics. And we have this repository of knowledge gathered by the most brilliant minds doing how many wise and liberated people have added to this knowledge base. And they have Vedanta is the science of consciousness. If you want to understand Vedanta, if you want to understand consciousness, why start from scratch when there is this huge repository of knowledge gathered by the most brilliant minds of that era, or of ever, in fact. So that is why I think we should learn both these subjects. And I feel Vedanta has the ability to answer many unanswered questions in quantum physics. So I am going to try answering one of the most fundamental and the most challenging question of quantum physics, the observer paradox. How is it that an observer is able to bring a particle into existence by doing nothing? By not even being part of the experiment. Simply the fact that a person is going to observe a particle brings it into existence. How is it possible? So we have seen the parallels in Vedanta. Sakshi Chaitanyam brings the universe into existence, and here we have an observer bringing a particle into existence. But they are not identical, right? You may say, okay, even if I accept as a science people here, even if I accept that there is a universal consciousness bringing the universe into existence, Why would a puny little scientist in a tiny little laboratory be able to bring a particle into existence? Although it appears similar, it's not the same. That can be an argument. So we can resolve it with the knowledge of Vedanta. So what does Vedanta say about the individual? What is the highest teaching of Vedanta? You are Brahman. I am Brahman. Aham Atma. I am Atma Brahma. Aham Brahmasmi. So it says you are Brahman. You are not part of Brahman, portion of Brahman, a section of Brahman. You will not become Brahman. You are here and now Brahman. So what does it mean? The first question that will arise is, I am this puny little human being with the mortal body and limited mind. The universe existed long before I came and it's going to continue to exist. How can anybody claim I am Brahman? So when Vedanta says, I am Brahman, it doesn't mean this body and mind. It means that all-pervading consciousness. So to understand this better, let us go to our dream analogy. So you're dreaming. In your dream, there are not just objects, there are other people. Let's say there are 10 other people in your dream. They are doing many things, isn't it? They are seeing, hearing, singing, doing a lot of things. So where do they get their consciousness? How are those people conscious? They are conscious because it is your consciousness that is manifesting in all of them. So how are you able to make all these conscious people in your dream? Have you divided your consciousness into 10 different portions like cake and distributed it to different people so that there are 10 pieces of consciousness? It's not like that. You are one undivided consciousness manifesting as this multiple consciousness in every conscious person in your dream. So the experience of every person in your dream is your experience. Let's say you're watching a sunrise. Let's assume you're watching a sunrise in your dream. Somebody is watching a sunrise. How are they able to appreciate the sunrise? It is you who have created the sunrise and you who are experiencing the sunrise through the person in your dream. So the experience of every person in your dream is your experience. So the consciousness of every person in your dream is your consciousness. But you are one undivided consciousness appearing as the multiplicity in your dream, isn't it? That is true about Brahman too. So when you say you are Brahman or I am Brahman, we are meaning that one undivided consciousness which is appearing as many in this illusionary world. So if this Brahman can bring the universe into existence by simply observing it, won't every conscious being be able to manifest that power? So we can never say an observer is puny, because the observer is that consciousness which brought the whole universe into existence. So that is how I feel we can resolve the observer paradox in quantum physics. So I feel there's a lot of value. Both these subjects can add to each other. Quantum physics can benefit from the huge knowledge on consciousness that Vedanta offers. And Vedanta has always done thought experiments, logic and analysis. We did not have the experiment and technological might to prove a lot of the findings of Vedanta. So quantum physics can give its technological and mathematical rigor to Vedanta and elevate it to the level of science. So both have value to add to each other, and together they can be the real science of consciousness. And Advaita Vedanta, not only the observer paradox, it has the ability to answer many outstanding questions in physics. We know that universe is fine-tuned for life. All of you who are in the physics field will know. So why nobody is able to explain why this fine-tuning is there, why the entropy of early universe is so low. What is consciousness? The definition itself is a struggle for science, but Vedanta has a clear definition. Who is an observer? So all these questions can be answered by combining the findings of quantum physics and Advaita Vedanta. Thank you, and Hari Om.